I welcome Monimoy for this podcast. This is a kind of a podcast where we are trying to demystify how you can be one of the influential engineers in any field that you chooses. You know, it's not about whether you choose a computer problem statement or else whether you have chosen absolute deep learning problem statement. It's all about your approaches, and engineering is all about approaches. Nobody cares about what your profit was or else until and unless it's more approachable. So now I'm going to give a brief view through this podcast about how to be an engineer, how to evolve as an engineer, how to make a plan as an engineer. So probably I think one of the person who has done a lot of micromasters, a lot of courses, and a lot of technical aspects involved in him. Like he has worked in different aspects. So I think probably it's going to be one of the unique piece of content that I'll be giving out to the world so that world can really understand what's that approach of an engineer need to be. Thank you so much for doing a podcast, sir.
Okay. Yeah. Okay. Thanks, Vishwas, for giving the opportunity to taking the podcast. It's a really really a opportunity to expose myself to the world and things. Okay. Thanks. All this.
Thank you so much, sir.
So yeah.
I think you can.
So basically, when I started way back in 1997, I was more of a developer. Okay. So my focus was solving some uh, some problem. Okay. And then I try to understand. Okay. As I evolved, I try to understand what is the why the problem is solved, like how it should be better be solved, and how it can solve customers or maybe end users problems. Okay. And then coming up with a maybe newer ways to of getting the same better solutions. So one of the instances I can tell you is that that is actually came up while I was working on my last company. Okay. So basically, when executives used to call, right? So they might their calls are very expensive calls, right? If there is a problem in the system, right? Okay. So they can lose millions of dollars of revenues, right? Because let's say it is a some backdoor deals going on, right? And there is a problem with the video, okay? And some of the executives are globally they're joining the calls, and they cannot some reason they could join it or some issues happen. So one of the features that came up with myself and my team together in this case is that how we cannot have a test call kind of things. What is test call is going to do is that, okay, before this meeting happens, it automatically starts a mm, simulated call. Means it's not an actual call, but just a simulated call it to start. And then checking that was everything fine or not. Okay. That will be done maybe 5 minutes or 10 minutes before the actual calls, and then we get this data, right? If everything is fine, okay, then all well good. Or if it is a problem and things, that reports will be sent to the whoever admins and things, so they can take the actions and stuff. Okay. So this is one of the we came to know from my knowledge of collaboration thing how this is important. Okay, so those kind of things, right? Solving actual customers' problem is a main focus. Okay.
True, sir. That's true because when even if you get in as an intern, it's not like you are not supposed to be an intern itself. You can find some flaw in the way the business flow is happening. You can find the actual ways in which things are not working proper, but some jugaad has made it work. So you can really clear off those aspects, and you can really make sure that system can be more rigid and more sturdy enough for the future computation. Like, आपकी राय क्या है about this modern days era, which is actually saying certificates matter today, micromasters, and the amount of certification that this our era is doing, like 100 days, 100 certificates, lot of nonsense which is coming up. And like you have done micromasters from MIT, and you actually dedicated some amount of time in order to complete the assignments, about taking the exam and a lot of things. Like, what do you really feel about today's new agenda of having as many certificates as you can?
So I just wanted to means few things I wanted to point is okay. One is that means world is changing. Our area era, okay, means even offline courses were the more important things. Nowadays, everything means you can get the very quality courses and you can access to quality professors, right, remotely and stuff. Okay, and this is going to the means um, coming generations, right? It's going to be the stay there, not going to. So earlier this online, this is going to change. Okay. And think about it right now on the US, all this COVID situation happened. A lot of students are taking courses from the home itself, right? So we cannot ignore those stuff. Okay. So the second thing is about your questions about the certification stuff. Okay. So basically, I can tell you my MicroMaster's journey first. We can tell MicroMaster that I did for Massachusetts Institute of Technology, right? MIT recently. Okay. So what I found is that actually I started machine learning all this time around 4 years back. Okay. And what I found is that means there are aspects. Okay. One is that you need to be hands-on things. Okay, you need to understand how the systems work, fully hands-on thing. And another is you need to understand how things work. What are the theories behind it? What are the means why it is if it is done this way, why it is that, right? So one of the things that I found is even machine learning, deep learning, anything we take, right, reinforcement learning. The main thing is that it is based on mathematics and statistics. Okay. So if those fundas are not clear, whatever you put it, right, code, anybody can do it, right? This is just a kind of few lines of thing. Even lines of code, you can do anybody can cycle learn the stuff. If you don't understand, right, if you means any systems, especially machine learning, deep learning. Okay. So main problem is that, okay, when you go to actual production, right, and you see that, okay, maybe any accuracy and things you can get maybe 90%, 95%, right? But when you go to the actual things where you needed to do the test accuracy, which is matters, and the data which is not seen. Okay. So here it may 30% of things. So the systems become unusable. And if you want to make the systems stuff, you need to know the insight into it. Without that, that thing does not certificates and things does not make you stop. So my microprocessor things what I see is that it gives me a solid foundation of probability statistics, machine learning, and analysis means the analytic stuffs. Okay, these are all a lot of. I had to solve around 1400 means very tough problems and things. So these are all problem-driven stuff. So and then when I augment this with my means hands-on knowledge. Okay, so I was actually training from last 2 years or so. I'm in training from the School of AI, right? More than two, you would say. So different courses I use things, so hands-on things. So hands-on but theory, I augment together, then my knowledge becomes completely perfect. So it's I mean to say is that I do not to develop any certificates and things. If it is really directed towards things, it is going to really values. And means I can tell you that means a lot of professors in that whatever insights they get in problems, right, is more important because what we need is that the whatever their kind of knowledge, their experiences, right? Okay, how they solve the problems. Okay, and also you are interacting with different students and all these things, right? Knowledge, and when you solve some problems, there are different ways to do it, and you go stuck, and you can get help some things, and then you find new ways to doing it, right? So I don't think means certificates are means. Certificates are really admirable, but if you need to do it, use right ones. That's the thing.
Yeah, doing right ones are the better thing, like instead of giving out numbers and selling out saying that okay, I have done so many courses, but what's the value that you have derived? It's better to do some finger countable cursors, but derive immense amount of value from it. Like you told a lot about statistics, probability, mathematics, like in a very short way on doing micromasses, deriving an hands-on experience from that. Like, how can you define intelligence today? Like machine level intelligence. There are Cisco routers which are actually having some machine learning models today in order to give an non-phishable, like no attacks, like which reduces the ways in which you are prone to getting attacks or anything like that. Like how far have you seen the potential of a machine level intelligence tomorrow?
So the machines, if you think about it, right, what we are learning, right, it is learning from human intelligence only, right? So basically means all the in the machine learning and all these things, the more important thing is data. Okay, how much data we can get it, how much data experiences we can get it, where it is data, right? That is more important than things. Okay, so you gave the examples of attacks and things, right? Okay, that is means you get a lot of signatures, right? Okay, signatures. So variety of signatures. If you can train it properly, right? Means attacks can come from different and different kinds of attacks are there, different kind of article, their signatures and things are there, right? And it is not one or two and things, right? It is a maybe millions of stuff. So the thing is that if you build a system which can predict the unknowns, okay, which you've not seen, new attacks come, you can tell, oh, this is maybe an attack and things. Okay, so there means I think intelligence comes into picture. The thing is that things which are known, it's okay. When it's not unknown, that's more your stuff. Okay, and also another thing is that machine learning things, there is one limitation is that it can a lot of times we do the classification stuff, right? So if a 10 classes there, one of them they need to this is the class. Not necessarily that. Sometimes you may not be able to tell anything. Uh, that time I think there are new technologies, Bayesian statistics and things are coming into picture, which can tell that no, I do not know. Okay, which is not out of 10 categories, right? It may tell that none of the categories it's like nota in our election system, right? I do not know. Okay, this is also another category, right? Okay, so another thing is that we are actually this is ultimately what is doing. It's automation, right? So automation means is trying to be better than human. So if it reaches at this human level, that is itself is a big achievement. Okay? And for that, we need variety of experiences and also, of course, models and things come into which if you don't use the right models and stuff, is of course you not scale well. After the models are done, right? So we have to data and we can, of course, we can do a lot of augmentations, right? A lot of scenarios you cannot do it humanly, not possible. Okay. So there are a lot of augmentation tactics and things we need to put it, okay, so that we can variety of data, right? The more variety of data you do and more tunings you do, more better results you can get it. Okay.
Yeah, that's true, because when we have a lot of data, that's where machine gets that insight and it brings its own intent. Like that's how we are building that software more towards, like, that's sure. But like you have also worked on computer vision.
And
Yeah, you can.
one more thing I want to tell you is that not only it should learn from his own mistake. Okay, it should not be a thing. That's what I think reinforcement learning and all these things coming into picture. Okay. So it's not that we need to feed your thing. It's not we do not think that this is a child, right? It should grow itself by time, and
Evolve itself.
that's only possible if we are using the reinforcement learning stuff.
But like you have also worked on computer vision, like
Yes.
lot of problem statements. I can't say like how many problem statements you have worked, how many projects you have done, but like computer vision as a problem statement, how have you seen it evolving over the course of time? Because you told neural networks, like, and simple CNN can't understand a text data or a JSON data. It has to be in a form of an image. That's where the pre-processing comes into the picture and a lot of things. But I want to ask you this one question, like how has this problem statement in computer vision evolved over the course of time? Are there still any canonical problem statements that are yet to be solved and not yet solved?
So the computer vision means traditional stuff, right? There are traditional computer vision technologies and then which is statistic based and things. So that was the ruling, and we have OpenCV and all this DLIP packages, all these things were used very beginning from there. Okay. So next come these means learning techniques. Okay. Convolution neural networks and all these things. Okay, so they actually means initially they were means when they pick up around 2010 to means those years and things, right? Okay, so it is actually means more matured now. Okay, so there are a lot of architectures like ResNet, okay, DenseNet, and all these things are coming, right? Those are kind of giving a fair good amount of accuracy. I would say that computer vision is one area which is actually deep learning starts from there, okay? And that's why we see a lot of maturity there, okay? Compared to NLP and all these things, which is still maturing. This area is more maturing. So I means what I want to say that if you see SOTAS and all these things, you will see that means classification the means maybe 98% accuracy is already reached or 99% accuracy is 1001, maybe it's a extra things it's getting. Okay. But what is happening is that means computer vision has different kinds of problems, right? So one is classification, that dogs, cats, and all these things, right? And that is one thing. Second thing is the object means recognition and stuff. Object detection. Next is the segmentations and all these things where we can get, let's say, some from X-ray image, cancer, all this X-ray or whatever means diagnostics your things, right? You know whether some cells are cancerous and all these things, right? Those things are in the picture. Okay. So I mean, so this has evolved, and a lot of architectures are unit and all these things coming into picture, and it's a fairly more mature things. Okay. But what is happening is that customizing different problems, right? Okay, so every customer has got his own problem. So what I want to say is that means the technology is mature. At the same time, there are a lot of applications, yes, applications. Okay, so the thing is that right now, a lot of tracking technology. Let's say somebody is wearing mask or not, right? It's very important, right? Like, let's say means kind of there are technologies we can find out and that somebody is what's called, let's say a COVID patient is detected, okay, in a office area. Okay, we can actually find out which areas is visited. Okay, has it really wear a mask or not? I think, right? Entry area. So we need to track that all these things made from the video scans. So those kind of things actually we need to tunings. Fine tunings is more can be done. And another thing is that because of transfer learning and things, you don't need to start from scratch and things. Okay, you start download some models and stuff, okay? And then using pre-trained model, you can tune it your data and fine tune it. This area is more kind of works are there. Okay. But as a technology, it's more mature than other areas.
Yeah, I know, but like, will this make sure that the GANs will be the next de facto standard? Like generative adversarial network will be the next de facto standard for building anything. It's like, all these days we used to say that if nothing works, just go behind the reinforcement learning. Somehow you will get the insights, intent, and neural networks will start to reason something. But like, what will be the fate of GANs in the tomorrow's world?
Okay, so GANs actually as a technology is earlier the problems were only on classification things. Okay, so but if you want to do something which does not exist, and you wanted to make out of nothing, right? To build new things, right? That's what GANs into coming into picture. Let's say you wanted to have a new design, new furniture designs, and which is never existed. Nobody has seen that, right? Okay. Those cases, GANs is kind of stuff. And I think I also worked on something like, let's say, there's something called cycle GAN. Okay. Where what you can do is that, let's say my means a lot of pictures are taken, let's say 30 years and 70 years and all these things. So when to know as a person when he goes old, how he looks like. Okay. So cycle GAN and things using some of the loss functions and all these tuning things, right? It can actually do those kind of things. So you can see if you are younger, how it look like. If you are older, you will look like. That's stuff. Or maybe whatever images of cars, right? You want to do a new design of car. Those it can build on means knowledge that you give. So it's not like restricted to our classical classification problems, and it's a more artistic thing, right? And one more thing is that it can be used for the that augmentations that I are talking about. A lot of images you cannot get it, but you can do augmentation techniques to get it, right? So GANs is also giving a very good quality images with augmentation, but at the same time, GANs are very expensive. It's long time to train. Okay, so to get the better quality images with GANs is very kind of costly thing. Okay. That also needs to be factor. Into consideration. Okay. But there are a lot of applications and things like I want my voice to be a bit like Amitabh Bachchan. Right? Those things, everything can be done using GANs. Okay, so it is going to be a revolutionist thing, okay? But at the same time, there are a lot of risks also there. Okay. Anyway.
But you have worked on I think probably you have worked pretty much amount of problem statements in NLP. I know that for sure because we discussed about how you generated the programs using the GPT-3 and all these things, and you have seen how GPT-2 and GPT-3 have evolved. I know, but like might never not worked on them, but like how these models have evolved over the course of time. But let's speak about transformers today, the new big thing. Trust me, I am not making this up, but it's going to be the new big thing. But like I just want to ask you this one question: what will be the next generation of it be to the world? Like what can it bring in as a potential in the future?
Transformers meaning? Transformer.
Like what can it bring in the future? Like what if this transformer evolves over the course of time? What can it bring in as a potential to the world? Like we are using transformers for the NLP problem statements, and we are actually getting some more data sets, and we are making decisions today. What can future generations of transformers bring to the world?
Okay, so transformers, as you know, this is actually NLP mainly as being used so far as being, and it's being more mature in the NLP technology, like sequence to sequence model. If you want to translate something, German to English, and all these things, right? Those cases, transformers and transformer main advantage is that it is parallel, right? Unlike LSTM and things, which is sequential, it is more parallel. Okay, and actually it is going to it is based on attention mechanism, right? So it can which images or which portion of words to give them more weightage, right? It can automatically find out. Now going to your question. First of all, I mean, transformers is now not limited to an NLP. Okay, it is actually going to the vision domain also. Okay. So already there are papers where means they can just like whatever is being used to NLP, this is going to the transformer as the next big thing in the convolutional networks will be by newer things are by the transformers. So transformers has a lot of potentials because of its inherent nature of parallel stuff, and also you can do encoder decoder stuff, right? So if you do encoder anything, encode it, right? Like you wanted to do from the from a video, wanted to know a textual things, right? Or maybe from image textual, wanted to textual interpretation of it. Those can be done using the transformer very well. Okay. And also another thing is that it actually, the LSTM and all these things, right? The main problem was that, okay, if it is a sentence and things become larger, right? Because of vanishing gradient or maybe exploding gradient, you cannot go further, right? It actually, the performance and things, calculuses get reduced because of those problems. Okay, but transformers does not have any kind of limitations as such, right? So it is, I see a variety of applications coming out of transformers, okay, especially as it already entered vision domain also, right? So I think that will be the next thing, probably after the convolutional neural network system.
Reinforcement learning, reinforcement learning has recently caught my mind because like I really want to work on recent reinforcement learning. TFRX, TFRL was there, like it was all derived, like Q learning, every algorithm was derived. But like you won't get that actual thrill of building something using reinforcement learning until and unless you build something with some raw frameworks like TensorFlow or PyTorch. That's the kind of thrill we get when we are building. So I just want to ask you this one question. There are basic learning steps which deep learning actually gave us, like CNN, DNN, different flavors of CNN and DNN have come up. Like I want to know, what is it going to be helpful in the world tomorrow in solving some problem statement? Like if reinforcement learning gets used in this problem statement, it can derive a very bright insight from whatever might be the data set. Is it like, do you have any such things in your mind which can really say reinforcement learning will be the only de facto standard solution tomorrow?
Well, coming to your question, right? The reinforcement learning is not a new technology. It's there for I think 90s or 2000. In fact, I was getting some courses from the IISc. Professor Shalabh Bhatkar, the I think chairman of research department at that time. So he has been publishing papers from 2000, more than 2000, 2010, or all this. This is kind of, it's not a new old, means it's not a newer stuff. It is being, it is attention only recently. Okay, when this AlphaGo problem was solved, right? Okay, and it beat the humans also. Okay. More attention. So basically, if you see the unsupervised, supervised, and all the learning, right? So if you supervised learning, it's like child, you're giving some charts and saying that this is carrot, this is dog, and all these things. Okay. Unsupervised is like it's k-means or all the algorithms, you can find out itself what is the stuff. Okay. Real learning, the humans, we human, how we learn, right? How we learn means working, right? Okay. So we'll the way we think about childhood, right? How we learn it. Right? So it by different steps, we fell down, and from there on, we can do these things, or maybe cycle, right? How cycle we learn it. Okay. So reinforcement learning is built on those principles where trial and errors, right? We learn from the trial and errors. It's not that world has all the data. Okay, it is going to generate data and it's learn from there, right? So that's why I think reinforcement learning has been pretty successful this day. This attention. It's a lot of attention, and maybe next 10 years, it is one of the technologies which is going to be a lot of potentials. Okay. Even think about all these models that you're generating, right? Okay. So now, handwritten, if we do it, right, we change some parameters and then you get some accuracies. How long you can do, right? You cannot get those things. Okay. So reinforcement, using reinforcement learning, it can automatically, it can change by different maybe layers, extra layers, kernels, all these things, right? Because it's trial and error. They can, using the evaluation policy, it can determine, right, which actions to take and things. Okay. So reinforcement learning main basis is kind of like say MDP. Okay, arc of decision process, okay, where you need to states, actions, and rewards you need to. So basically, the way we learn, right? We if I get fell down, then we get negative reward, right? If we are successful, right? Somebody gives a positive reward, and we know that it's the right way to do it. Same way it is learning, and it's going to be. Means I'm going to say is that it is going to be a game changer, and there are a lot of questions, right? Okay, uh, uh, and especially I can tell you is that in our network industry, okay, whatever protocols that's there in new things, okay, those protocols can be more efficient by reinforcement learning. Okay? And I've been working on some of the means not in networking area, but self-driving. Self-driving some simulations and stuff. I got some blogs published there. Okay. There also I used the reinforcement learning, and I saw that kind of it's a kind of it is it takes little time to learn. Okay, once you learn it, you feel the enjoyment. Okay, especially in gamings and all this stuff. Right? So whatever my experience here, right, I can tell you is that okay, initially you will have a lot of frustrations. You'll see that things are not learning and things, but once you go to the right strategies, and after maybe few hours or maybe few days, you'll see that means rewards are coming like anything. Okay. Then you feel the satisfaction, and then you will say that everything is kind of coming. Means, but it is going to take a long time to train. But there are also techniques. Okay. So another thing is that in-person learning may take a long time. So there are techniques like genetic algorithms is also coming into picture, where you don't need a high GPUs. You define solutions and things, define seed solutions, and you can take that, give it to the genetic algorithm. You can find out the better solutions, right? Okay.
Well, like you have deployed many models for sure, because while learning itself, we all build models to deploy, but many a times we don't deploy the models, and we literally say, okay, like I've got some result, I've got some accuracy, let me just leave with it. So I just want to ask you this: what are the learnings that you got just by deploying models? Because you have worked on different clouds, you have worked on different frameworks, you have worked on different models, transfer learning models, and so on. Like, what are those learnings that you got from deploying models? This is the
So,
newest thing that we need to answer, because if we don't answer it, probably there are going to be less models deployed from our side tomorrow.
yeah. So basically, any training and all these things is just getting a model ready. Okay. But real means money will be coming from your deployment. So you need to deploy your model, whether it is edge device or cloud, all this stuff. Okay. So the thing is that I have deployed a lot of models in, especially NLP and vision models in AWS. So there are sometimes I did the EC2. Okay, but EC2 is very expensive. Okay, the problem here is that, right? Okay, uh, because of free tires, right? The resources are very constrained. Okay, and if your model is very large and things, right? Okay, how do means accommodate things into the your whatever deployment parameters given. You cannot. There are a lot of constraints are there, right? Your size should not go beyond uh, GB or maybe MBs and things, right? Okay. So that what you need to do, you need to prune the model. Okay, and that's a challenge. Okay, lot of times what happened with the TensorFlow deployment and things. If you do the full TensorFlow and put it in it will take your your full size, right? And you cannot deploy anything, right? Okay, so then you need to take the particular packages. Okay, and you need to even there are techniques to kind of tune your models also, so that you can we can whatever maybe give you some model if we can few MBs and things, so that you can deploy easily, right? So another thing is that about you need to have uh, this is a prediction, right? Okay. You need to have parallel predictions and things. Okay. So TensorFlow, Slark, and all these things can solve those problems. Okay, because it may be possible that there are millions of customers are using your website, right? Maybe you are selling some maybe car parts or detection or something like this, right? So if they cannot get the results in the real time, they'll be kind of get out of, means they're not value, right? So that is parallel things is also another important thing. Okay. So the thing is that deployment is another kind of we can say engineering, you can say. Okay. Training is one kind of engineering, deployment is another kind of engineering. You need to understand that you need to do things using whatever resources given. Okay, you will not get enormous resources and things. Okay, if it is a small device, you cannot expect that you can fit into the means easily, right? Okay. So those we need to work on it, and we need to know technologies and whatever needed, right? Okay.
Last question, sir. Last question about the patents, because you also have an US patent, which is actually a dream of many people. Actually, Indian patents are something which people want to do at the first, but like US patent is actually a dream. Like, how was your journey? While I know you can't say the professional aspects of it because it was done through a company and things like that, but like, how was the journey when you actually got the patent, and how did you feel when you received the patent?
So I have got two US patents. So first one is from Juniper Networks. So that is about pseudo-ware provisioning. Okay. So basically, what's happened is that there's a protocol called netconf, right? On netconf, you can provision configuration stuff. What is happening is there are a lot of times when you provision, right? Okay, the provision does not go through, okay, because there are a lot of reasons. Maybe network there was no connection to the device and all these things. Okay, and pseudoverse actually it is actually a end-to-end connections, right? So if one side is provisioned and the side is not provisioned, okay, it will be hanging stuff. So, and a lot of devices does not have any rollback capability. So automatic rollbacking is configuration thing. Okay. So that this patent actually, first patent actually takes care of devices which does not have rollback capabilities, means how to do the automatic rollbacks and things like those. The second patent is filed from Cisco Systems. Okay. And that is about, I think I mentioned a little bit about that setup diagnostics. Okay. So basically, whenever we, a lot of times we are not able to, whenever calling the phone, it is not connecting and things, right? You cannot set up the calls because when we're calling another person, right, is not setting up. Okay. There are a lot of reasons for that, right? So basically the call signals, right, is like C2 3, all these signals actually that are also messages, protocol messages are exchanged. And in between, though we see the only end devices, but in between there is there are a lot of devices involved. And every device has got its own kind of technology, how to encode the, let's say, call number and things. Okay. It has got IDs, different formats and things. So this patent is about stitching everything together. Even if it does not have standard call format, it can stitch it using some mechanism. That's the mechanism of different attributes and things, right? Okay, and then stitch them together so that we can have a complete letter diagram of stuff. So that is actually the second patent, which is the US patent.
Thank you so much, sir. Thank you so much for this amazing podcast where people don't get to know about just being okay. We are just deploying models. Then what? We are just going high in our career. Then what? You need some satisfaction of work. I think probably doing patent, doing research is actually going to give them a lot and lot of insights about what should their future look like. I think thank you so much for this podcast, sir. Thank you so much.
You too. I mean, it's a really opportunity, giving me an opportunity to tell my side of story. Okay.
Hey folks, good afternoon, good morning, at whatever time of the world you are. I think, trust me, you have to listen to this podcast completely because It's not about it. He has years and years of experience in this world of technology, and trust me, it's going to give a huge impact to all of you in order to understand what is it also all about. Like, I can give you a slightest of the slightest introduction about what technology is, but I think this podcast is something which is more unique and required by all of you to understand what it is all about. So make sure that you listen to this podcast completely and don't miss a chance to understand what this world of tech means to you exactly 10 years, 20 years later. So enjoy this podcast.